Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be looking at an equation with absolute value. So this looks like a quadratic equation, doesn't it? But it also contains absolute value, which makes it more interesting. And I think I will be presenting maybe two approaches, and let's start with the first one. So my first method is going to be pretty standard, and remember, when we have equations like these, we do replace z with something in a complex number in rectangular form. If you forgot, check out this channel's name. Yes, it is A plus BI. So we're going to replace z with A plus BI and then try to solve for A and B, which is going to give us z eventually. All right, let's get started. Replace z with A plus BI squared plus 6 times the absolute value, or the modulus of a complex number, is defined by the distance from 0. Therefore, it is the square root of a squared plus b squared from the Pythagorean theorem. Not the Pythagorean, it's the Pythagorean theorem. Anyways, so this is our equation. Let's go ahead and expand it a little bit more. This is going to be a squared plus 2abi plus b squared I squared plus 6 times the square root of a squared plus b squared equals 8. Now notice that I squared is -1, something that you should never ever forget, right? So we can kind of put this together with a squared. So these two are gonna make up the real part plus this one, and that would be plus 6 times the square root of a squared plus b squared. The only imaginary part is 2abi, and this is equal to 8. Great. Now, notice that on the left-hand side, we have a complex number whose real part I put inside parentheses, and whose imaginary part is 2ab. But wait a minute. On the right-hand side, we have a real number whose imaginary part is 0. So this is kind of like 8 plus 0i, right? Isn't it? There's a hidden 0 there. So we're going to set this equal to 0, which makes things a lot easier. So if 2ab is 0, that means ab is 0, and that just means a 0 or b is 0. We're going to consider two cases, okay? Now, of course, along with this equation, we also have another one which tells us that, hey, the real part must equal 8, right? So let's go ahead and set the real part equal to that with the knowledge that a is equal to 0. So if you replace a with 0, you're going to get negative b squared plus 6 times the square root of b squared equals 8. Awesome. That's an equation. We're going to hold, let's just hold on to it and then figure out what happens with b equals 0, and then we're going to solve each equation. I can call this first, and I can call this second. If b is equal to 0, we're going to get a squared plus 6 times the square root of a squared equals 8. Just like the first one, we replace b with 0 everywhere. Make sense? So remember, a and b are real numbers, and each of these equations have a single variable, which means we can solve it easily, right? Let's check it out. First of all, since b is real, what does square root of b squared mean? Let's talk about that first. Well, if b is a real number, the square root of b squared can be written with the absolute value symbol, right? Because it could be plus minus b equals 8. Now we're going to consider two cases. You can call this 1a and 1b. It's up to you. But I'm going to split it up. If b is positive, then we get negative b squared minus 6b equals, I'm sorry, that's supposed to be a plus sign, plus 6b equals 8. Because when b is positive, absolute value of b is going to equal positive b, right? So let's go ahead and solve this equation. Put everything on the right-hand side. You get b squared minus 6b plus 8 equals 0. And hopefully you know that this is factorable into b minus 2b minus 4. And from here we get b equals 2 and b equals 4. Since 2 and 4 are both positive, we're going to take them. We're going to accept them. Otherwise, we would have to reject it, right? So we got two solutions, b equals 2 and b equals 4 for b positive. But this also came from a equals 0. Does that make sense? So let's go ahead and copy that here. This is going to give us two solutions. And we're going to write them in a little bit, okay? Let's go ahead and consider the second equation. Well, actually, before we get into the second equation, I'm sorry, I still have to do 1b, which is going to be, which is going to be basically the second branch from here, which is b is less than 0. If b is less than 0, this is going to turn into negative b squared minus 6b equals 8. If you put everything on the same side, you get b squared plus 6b plus 8 equals 0. Again, this is factorable. B plus 2, b plus 4 equals 0. From here, we get two solutions, and they're both good because they are both negative. Remember, we started with the premise that b is less than 0, and both of these equations satisfy that condition. So everything is good so far. Again, this comes from a equals 0, so we're going to put it together again as two solutions. Make sense? So we're done with the first case, 1a and 1b. Let's go ahead and take a look at 2a and 2b. Okay, now, case number 2 is a squared plus 6 times the square root of a squared equals 8. Remember, the square root of a squared is the same as absolute value, so we're going to get something similar, don't you think? Right? Well, we're going to split it up into two cases. One is if a is positive, we get a squared plus 6a equals 8. Actually, this is not the same thing. You're going to realize when you complete the square here, you can also use the quadratic formula, but I like completing the square, so add half of 6 squared, which is 9 to both sides. You get a plus 3 squared equals 17. And then by square rooting both sides, you're going to get plus minus square root of 17. And subtract 3, you're going to get the answer as follows. But remember, a is supposed to be positive, so we can take if anything is negative. So let's go ahead and split it up into two solutions. A is either negative 3 plus root 17 or negative 3 minus root 17. Obviously, negative 3 minus root 17 is negative, so we're not going to take it. We're going to reject it. And this is positive because square root of 17 is greater than 3, right? It's even greater than 4, so definitely this is positive. So we're going to take it. But where does this come from? B equals 0. Remember that? So they'll basically be together. Make sense? Let's go ahead and take a look at the second case, which is a is less than 0. What happens if a is less than 0? Then from the absolute value, we get a squared. Notice that this is the equation we're looking at. Minus 6a equals 8. Again, by adding 9 to both sides, we are completing the square. That gives us a minus 3 squared equals 17. By square rooting, you're going to get two solutions. Add 3 to both sides, and you're all set. But guess what? We're going to split it up into 3 plus root 17 and 3 minus root 17. And we're looking for negative a values. Look at that. So 3 minus root 17 is negative because root 17 is greater than 3 again. So we're going to take it, but we're going to reject it because it's positive. So you have to be very careful about these conditions case by case. You have to work everything. Make sense? Cool, cool. Since this was 2a and 2b, we're done with both cases. Now let's go ahead and put this all together and see what the solutions are going to look like. And then we're going to check something with Wolfram alpha. Okay, so what do we have? We have 0 with 2 and 4, which means we have 2i and 4i as solutions, right? Because those are imaginary parts. And then we do have b equals 0 with a equals negative 3 plus root 17. That means we have a real solution because imaginary part is 0. And then finally we have the 3 minus root 17, again a real solution because imaginary part is 0. Make sense? So there seems to be 4 solutions. Let's go ahead and check them out. So this is the graph of the absolute value. Of course, this is for real numbers. With complex numbers, it's a whole different story, right? And then these are the real solutions as we talked about it, and the complex solutions we also talked about. So here's the problem. I told you that I was going to kind of show you like two approaches, right? Well, with the two approaches, obviously we have the negative 2i and the 2i as well. I don't know if I've written them down. Did I? Oh, okay. I think I should go with plus minus, right? Did I? Oh, yeah, I should consider both. Wait a minute. We have 2i for a yes, absolutely. So it's going to be a plus minus sign. Allow me to write this so that we can save some space. But yes, there should be a total of 6 solutions in this case. All right. And the solutions from Wolfram Alpha should also reflect that. And this brings us to the end of this video. Thank you for watching. Oh, by the way, I talked about a possible second way to do it. And I guess you could kind of proceed as follows. If z is real, then you can kind of split it up into 2 cases. But what would you do if z is complex? I don't know if there's another way to do this. You could take the absolute value, you could square both sides, so on and so forth, but I don't think that's going to get you anywhere. But anyways, this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.